Hello and welcome. In this video I'm going to complete a series of tasks for mpls on OcNOS devices. Let's take a look at the task first. The task says configure interiors mpls option B in this diagram and ensure connectivity of the customer. By connectivity I mean I need to have the prefixes from the other branch in this branch. And I have spoken about why would we go for interiors mpls configuration, but right now if you have not seen that video I recommend you take a look at that. And of course we have the theories about this completely spoken, but what I'm going to say is we have three types of interiors mpls. Option A was configured in a previous video. In option A what I did was I just said that each one of these service providers are completely separate from the other side. We don't really want to think about what is happening on our connection to the other service provider. We just assume that this is our boundary, and what we have is we are just going to assume that our customer is directly connected to us. This means that if I have something like a VRF green here, I need to have a VRF green here, and an interface or sub-interface ideally, of course, should be assigned for that VRF. So that is what we are going to do in option A. In option A, there is no MPLS enabled in this interface. It is just a VRF interface, that's it. And the other side is going to be supposed to be our customer, whether it is a service provider or the customer directly connected to us. Now, I have spoken about the benefits of that as well. For example, I don't really need to collaborate with the other service provider in a lot of different things, because my configuration is my configuration, and the only thing that is changing here is that's it. I have just a sub-interface connected to that VRF. Even if I had my customer connected to me, that would be the thing that I would need to do. What I mean by that is the configuration is not so hard, maintenance is not so hard, troubleshooting is not so hard, everything is going to be exactly the same. Training is not going to be so extensive. So option A is a very good option in case you want to do it super fast and super easy. But the thing is, this is not scalable. What if I have hundreds of customers here? All of them are going to have prefixes that this is going to install its routing table, and this is going to install it in its routing table. In this case, of course, there is no point in installing those routes in our routing table. So why would we do this if we have a better option? Now, MPLS option, interiors option B says that, okay, do not do anything on router 3 and router 4. These are our ASBRs. ASBR is going to be Autonomous System Boundary Router, which is initially our PEs as a matter of fact. But what is the difference? I'm not going to have any kind of VRF defined on these two ASBRs. VRFs are going to be defined only on this PE and on this PE. And between these two, we are going to enable MPLS as well. So MPLS is going to be configured here. And also I need to have LDP extension here, which means that I can create a direct session or a remote session between the loopback interfaces of router 3 and router 4. In this case, direct session is going to be better, because if I go with the loopback interface, then I need to have a route configured between these two. Static route maybe just to make sure that those loopbacks are accessible and reachable. But in this case, of course, I'm not going to do that. Just a regular session is going to be okay. And then a VPN v4 connection between these two, exactly the same as the VPN v4 connection that we have in here. But the difference is when you configure VPN v4 in OcNOS devices between eBGP neighbors, what you need to do is to say that you need to have this eBGP VPN v4 feature enabled. So that's just an extra piece of configuration that we need to do here, but that is not going to, make a lot of difference for us. So what I'm going to do here is to reconfigure router 3's BGP. So I'm going to just delete this completely. Let's take a look at the topology here. R7, I guess, has lost its configuration. Let's go to router 7 first of all. Yes, it has lost its configuration. It's not going to take a long time to configure. What we need to have is this Ethernet 1 is connected to here. So interface ETH1. I'm going to have an IP address of 10.177/24 for that. And also an interface loopback. I'm going to have an IP address of 7777/32 secondary configured here. And also because we are using OSPF to have an adjacency with the service provider, so I'm going to say router OSPF1, and I'm going to say router ID maybe is going to be this one, and also network is going to be this /0 under area 0 and area 0. And that's it. Commit the configuration, and we don't have anything more than that. So if I just say show IP OSPF neighbor, I should have an adjacency after some time here. And let's just say terminal width. It's going to be 256 on all devices. And let's go with this adjacency after some time. Okay. Can I ping 10.171? Yes, I can. So adjacency should come up in a minute. Or maybe I need to do some configuration on router 1 and make sure that this is available. So if you go to router 1 and say show IP, show running configuration router OSPF, I should have an OSPF configuration from before. And this interface connecting to router 7, which is ETH7, should be under this specific, what is it, VRF. So if I just say show run interface ETH7, it says that it is under this VRF. And if I say show IP OSPF neighbor, right now it doesn't seem that we are creating any kind of adjacency with router 7, which is kind of a funny thing. So let me just see. Here we are adding almost all networks under ABC. So if I just say show interfaces, here, not this one, of course brief is going to be enough. Here it says that ETH7 is under this. Neighbors are 0. Kind of a funny configuration. Let's go to router 7 and take a look at this. Let's say I'm going to check. So let me just see this. Show IP interface brief. Of course, do show. Here it says that our interface is up and up. To show run router OSPF. Here it is. That's the problem. It has not taken the network command. Network 0000/0 is going to be area 0. And commit, and then we should be okay. So if I just say show IP OSPF neighbor, now there is a neighbor here. Okay, let's go back to our other parts of the configuration. On router 1, I'm going to show you the running of router BGP. You can see that I have configured BGP 100. There should be a neighborship with router 3, and this should be activated under VPN v4. And as you can see, for this VRF ABC, I have created an address family, and I am redistributing the connected networks, and I am redistributing OSPF2. And of course, you saw that OSPF2 is redistributing BGP back. That is because we are just sending and receiving the prefixes from the customer. So we don't have anything else to do here. I show run VRF. Here it says that we have this VRF on with route RD11 and route target of 11. I'm going to do the same thing, exact the same thing on router 6. So on router 6, I'm going to say show run VRF. You can see that exactly the same thing is here, but route target both is 1 and 0. This is wrong. I need to just fix this problem. No problem, that's okay. On router 1 we have route target of 1 1, but here for some reason it says wrong. Okay, so if I just insert it, and I'm going to say no route target this, but route target both should be 1 and 1, then I'm going to say commit the configuration. Okay, the next piece of configuration should be router BGP configuration. As you can see, the same thing here. What we have is we are having this address family VRF ABC and also an internal VPN v4 connection between this and this router. And of course, this interface should be under VRF ABC. So if I just check running configuration of ETH7, you can see that this is under ABC. And of course, if I say show run router OSPF, the same thing is here. Which means that if I say show IP OSPF neighbor, I have an adjacency with my customer. The other one, of course, is internal service provider network, but this one is under VRF ABC. This is important thing. Okay, so everything seems to be good, and I have, of course, mpls enabled using label switching, and also LDP enabled using enable LDP on these internal interfaces on both service providers. But router 3 and router 4 are going to be the most important part. Router 3 and router 4 do not have to have any kind of VRF configuration. I'm going to reset their BGP session. So on router 3, I'm going to say no router BGP 100, and I'm going to commit this configuration. And if I say do show IP VRF, you can see that there is no VRF configured other than the default VRF, which is the management VRF here. So we don't need to have any VRF in here. What I need to say is router BGP 100. I need to say my neighbor is 1111, which is in remote AS 100. And I need to say update source is going to be 3333. You can say loopback, but because I might have some other addresses configured for loopback, I really want to go with a specific IP address. And if I say address family VPN v4 unicast, I can just enable this activating this neighbor here. And by default, of course, those communities, extended communities, are sent and received for standard and extended. Okay, so let's exit address family. Now what I need to do is to create a VPN v4 adjacency between router 3 and router 4. That is going to be important. Let's go to router 4 and do the same thing. I'm going to say no router BGP 200, whatever the configuration is going to go away. There is no VRF configuration here, so let's say router BGP 200. It's going to have an internal neighbor of 6666, so it should be in remote AS 200, and it should be using update source of 4444. And under address family VPN v4, we should have this activated. Okay, so let's go to here. Now, the adjacency between router 3 and router 4 is going to be very important. So let's say I have a neighbor with 10, 10, 34, 3, which is in remote AS 100. Let me see, do show run interface ETH3. This is ETH3 between these two. 10, 10, 34, 3 is going to be the other side. Okay, now I'm going to say address family VPN v4, and under this I need to activate this neighbor. So I'm going to say commit. The same thing goes on the other side. But what is this one? It says that because you are trying to activate an eBGP VPN v4, you need to have this allow eBGP VPN. That's okay, very good. I'm going to say allow eBGP VPN for this neighbor as well. Then I'm going to say commit. Interesting, right? Now, something else that you should know. When I am sending these messages to the other side, I really want to make sure that those are not going to lose their extended communities. They are not going to lose their route targets, which is an extended community as a matter of fact. And for that, I need to say no BGP. Let me see. Exit address family. I'm going to say no BGP. There is a command here that says inbound route filter. And this is going to kind of disable this, just to make sure that we are not going to have any kind of a problem. So let's commit this. And now we have no problem. The same thing goes to the other side. So I'm going to just use this. Go to router 3. And I'm going to say this. And I'm going to say 10, 10, 30, 10, 10 of course. 10, 10, 34, 4 is in remote AS 200. Under address family VPNv4 unicast. I need to activate this, and I need to say allow eBGP VPN. Then I need to commit this configuration as well. Next piece of configuration, I need to make sure that LDP and MPLS are enabled on this interface, because I need an LDP session, and also I need to send some labeled packets to the other side. So if I just go to interface ETH3 in this case, I'm going to say, first of all, label switching, and also enable LDP, in this case, of course IPv4. So I need to say commit. The same thing should go to the other side. So interface ETH3, label switching, and enable LDP IPv4. That's it. Almost all pieces of configuration is done, and we are completely set to go. So what did we do? There is no VRF setting on router 3, no VRF setting on router 4, which means that we are not going to have any of the prefixes in our routing table. There is a BGP VPN v4 setting between router 3 and router 4. There is MPLS here, and there is LDP here. Now let's go for some verification and see what we have on router 3 and on router 4. So first of all, on router 4, of course, the same thing is going to happen here. So let's go with this. Show IP BGP, VPN v4, all summary. Okay, I have two BGP VPN v4 adjacency. One with my PE, internal PE, one with the other one, the ASPR from the other network. And the number of prefixes that you have received it is 2, which means that if I just go with all, this means that I am receiving some prefixes from the other side. These are internal, which are marked with I, but this one is external, and you can see which autonomous system has sent it to us. And also because we said redistribute connected on the PEs facing the customer, this is the other one that we can see. So this part is good. I am receiving the prefixes. Let's do the same thing on here. So I'm going to go with this on router 3. Let's save everything first. And okay, we have these sessions. Very nice. And also the prefixes are here. Very nice. Do I see the prefixes on router 1 and router 6? I should go and check it. On router 1, I'm going to say OcNOS, just to log in. Okay. Summary, I have router 3 here. Very good. Terminal width is going to be 256. And if I just want to see the prefixes, Great, I'm receiving the prefixes from the other side. So this is from AS200, and also, did I increase the terminal width or not? I did. Very good. And also this one is the connected network from the other side. And great, very nice. And what about router 3? Let's check. On router 6x, of course, not router 3. Okay, I'm going to save everything. Okay, summary. I have router 4, and if I just say all, great, I'm receiving all the prefixes. Now, the only thing that we need to verify is all of those prefixes are on router 7. That's all. And of course, I can just go with some more verification commands here. On router 4, actually, I need to say what is this prefix that I have received from the other side, from, for example, 100. So if I just say show IP BGP VPN v4 all, and after that go with this prefix and hit enter, of course without this subnet mask, and hit enter. The interesting thing is I am receiving this and I seed my route target on that, which is great. And here it says 00. Let's go to router 6 and check something. Show IP VRF. Great, everything seems to be good. Show run VRF and hit enter. Okay, seems good. Let's go back to router 3, router 4, of course. So I am seeing this route target here, which is the extended community, which means that it is sent to the other side without any problem. No filter on that. It says that we have the next hop set as the other neighbor. Now this might be a problem on the other side, because we need to either advertise this link into our network or change the adjacency between router 1 and router 3 to have next hop self configured on that. Let's go to router 1 and do the same thing here. I'm going to use this one, or router 6 actually, because this is from this side. Let's go to router 6 and check this one. Here it says that the next hop is this one. Can I reach to this? Ping here. We cannot. That is because the other side doesn't know about us. What about this one? We can, because we have advertised it to ourselves. But the same thing should not be true about this one. That is because we are using OSPF and we have just tried to have this interface as passive interface. But this side we are using ISIS and we have not advertised this into ISIS. Or maybe I have. I need to just check this on router 3. So if I just go to router 3 and say show run interface ETH3. Okay, I have advertised it into ISIS, which means that this is good. But again, this doesn't really mean that router 1 can really reach to this network. And if I just want to make sure, I need to check something there. So on router 1, for example, I'm going to check 8888. Okay, so it doesn't say it is not inaccessible, but as a matter of fact, the next hop is something that I don't really like it. What I need to do, I just really want to change the next hop to router 3 and here to router 4. Each one of them can be configured in this way. Let's do this. On router 3, I'm going to go to configuration mode. I'm going to go to router BGP 100. And I'm going to go to address family VPN v4. And under this, I'm going to say neighbor 1111. And I'm going to say next hop self. This might not be really necessary, but I really like to do that. So on router 4, configure terminal, router BGP 200, address family VPN v4 unicast, and under this neighbor 6666, I need to say next hop self. I'm going to commit this configuration. So let's go back to router 1 and try this one more time. Now you can see the next hop is 3333, which is interesting, more interesting actually. And you can see that for that we have a label as well here. Okay, the last thing that I want to do is to just make sure that my customer has received these prefixes. So if I just go to router 7, OcNOS, going to say show IP route, and I am receiving the prefixes from the other side without any problem. And router 8, of course, show IP route. Router 8 is receiving the prefixes from the other side without any problem. So everything seems to be okay and working, and that is the configuration. So I hope this has been informative for you, and see you in next videos.